Okay, Mr. Phobes here. This will be the first of three color mini lessons. The first one will be on basic color concepts. The second one will be on the color wheel, and the third one will be on color perception and color saturation. So starting out with color concepts, if I think about all the things that I have to teach to students is my um, knowledge and experience with color. I've been exploring color for over 40 years. It's a big part of my practice. This is a painting that I did in 2011 that exhibits a lot of what I'm interested in color. One of the things is that if you look at this painting and you look at these gray rings, and there's a gray ring every other ring. That gray is the same gray as it works through the painting. Look how different the gray is here, how green it looks next to the reds, and how violet it looks and lighter next to the blues. This is also a form of simultaneous contrast. We've seen this with the grays, so it gets even more pronounced when we start working with color. So this is a great quote from Joseph Albers, who wrote a book in 1971 called The Interaction of Color. He says, if one says green, the name of the color, and there are 50 people listening, it can be expected that there will be 50 greens in their minds, and one can be sure that all these greens will be very different. Color is the most malleable of all the elements of design. And the reason I say that is that if you think about line, shape, texture, value, and color, values certainly we can manipulate. We've seen that we can make, depending on whether it's a dark ground or a light ground, that the gray can look lighter or darker. But it's even more pronounced when we start working with color, and we can really make colors seem to change. If you look at this model here, this yellow green and this yellow green are exactly the same green. Stare at the line right here. Don't stare back and forth between, but stare at this line. Stare at it for a few seconds, and you'll see how much that green starts to change. On the right, it should start looking very blue and cool. On the left, it should start looking very warm and yellow. And we'll talk about more about that when we get into color perception, about why that happens. But this is just to demonstrate that color can be manipulated to change. So what are the important color concepts? The three physical components of color: hue, value, and saturation. This will be on every single test you have about color. Simultaneous contrast is the effect of one color on another when in close proximity. We just looked at that. Color temperature is the perception of colors being warm or cool. We've seen that with the grays. The ivory grays look really warm, and the Mars blacks look really cool. Additive color is color produced with emitted light. So right now you're probably looking at a monitor, and the color is being produced by light that is being projected towards you, and that is called additive color, and it uses a very special color model to create that. Subtractive color is color produced by reflected light. So when we think of things that are printed, or when we paint on a canvas or paint on Bristol board, that is subtractive color, and we'll explore what that means. So the three physical components of color: we've got hue, and that's the color name. So here we've got this very intense yellow-green hue. The value is the lightness, darkness, or luminosity. So we've already been working with that in grayscale. Um, so if I take this yellow-green hue, here it is right here, and I add white to it, it becomes lighter, and I add black to it, it becomes darker. Here we have the same uh, yellow green, and we're changing its saturation. Saturation means the intensity or chroma of the color, and it's the range from prismatic, its purest hue, to a neutral gray. So here again, here's that very bright yellow green right here, and it, as we move and add gray, it becomes a very neutral gray. We'll talk about these. These are called chromatic grays, and we'll do a project with chromatic grays. But this is to show you that the saturation changes. So down here we've got a neutral gray. This is a very, very desaturated yellow green, whereas here it's a very highly saturated or very intense yellow-green. The color models. So this is very important. There are three basic color models that we work with today. Red, yellow, and blue is the historic model every kid learns probably from second grade to seventh grade. It's the historical model that Painter's palette has been used to develop an art and design palette. And it too is a subtractive color model. It's based on this idea that when you mix the colors together, they go darker. RGB, red, green, and blue. That's the color model associated with color monitors. So when we're looking at LCD monitors, CRT, theater lighting, it's based on this model of RGB, emitted or projected light. This is called additive color, and that means because as you project those red, green, and blue together, they actually get lighter. If you project red, green, and blue all together, they'll become white light. And then CMYK, cyan, magenta, yellow, and black. It's sometimes called the printer's model, and it's used in color printing. This is also a subtractive color model. We will not be working in RYB at the beginning of the work in color. We will be working in CMYK. And there's a reason for that. You can probably guess. More and more color work is being done digitally, and I really believe that cyan, magenta, and yellow are the colors of our time. And we will be producing a painted color wheel using the paints that are in your kit, and they are cyan, magenta, and yellow. What's nice about this is that when we move to doing digital color, we'll already know how CMY work together, and it'll make it really easy to start working in the CMY model in the computer. Okay, so let's look at these. Here is the color model red, yellow, blue. It is made up of primaries, secondaries, and what are known as intermediates, which are not shown here. Primaries are prime hues. They cannot be mixed. It's like a prime number. It can only be divided by itself in 1. So you can't mix red in red, yellow, and blue. You can purchase the red, you can purchase the yellow, you can purchase the blue. So they're absolutely prime. The secondaries, which are violet, green, and orange, are mixed from 2 of the primaries. So if you mix yellow and blue together, you get green. If you mix red and blue together, you get violet. And if you mix red and yellow together, you get orange. And you probably learned that somewhere along the way in elementary school or middle school. The RYB model is a subtractive because as any of the hues are mixed together, a darker value is the result. Theoretically, all 3 primaries mixed together yield black. So here we go. Here's the yellow, here's the blue. Mixed together, they make green. The red and the blue mixed together make violet. The red and the yellow make orange. You mix all 3 of them together, and theoretically, you get black. Now, the problem with that is that we can't buy pigments that are that pure. We'll end up with something that's a very dark gray. There is a way to make black, and I can show you how to do that, but they're not equal proportions of red, yellow, and blue. Here's our cyan, magenta, and yellow. K stands for black, and it's actually not on the color wheel. And it's not used as part of the color model, but it is used in printing. So we'll call it CMY. So the primaries here are cyan, magenta, and yellow. And again, they are prime. They cannot be mixed. The secondaries, now this is interesting. The secondaries are red, green, and blue. Now what's really odd about that is that we know in our RYB model that blue is a primary, but in the CMY it's a secondary. Now here's another really weird thing. When you mix magenta and yellow together, you get red, which is primary in the RYB model. This makes a little bit more sense. Cyan and yellow mixed together make green. Again, if you mix all 3 together, you'll get theoretically black. So again, it's a subtractive color model. All the hues mixed together make black. And then the last model is red, green, and blue, and this is the additive model. Now This is interesting because um, red, green, and blue, if you think about it, we just talked about our previous model. Um, red, green, and blue are the secondaries of CMY. But what's interesting is that they are the primaries of red, green, and blue. And then what becomes the secondaries are cyan, magenta, and yellow. So the primaries and the secondaries of red, green, and blue are reversed when you go to CMY. Just a little interesting tidbit there. Um, the secondaries here are magenta, uh, yellow, and cyan, and they are mixed. When you mix red and green together, this is weird. Look, you get yellow. We can do an experiment where we take red light. If we have two flashlights, one has a red filter, one has a green filter, and we shine them in the same spot, you will get yellow. And that's a very weird thing. When you mix green and blue together, you get cyan, and when you mix blue and red together, you get magenta. So notice what happens when you mix these two colors together. They produce a lighter color. When you mix all three together, you get white light, and that's why it's called additive color. All right. Uh, this just shows the relationship of the colors between the CMY, the RGB. So here we go. Uh, R, I'm sorry, RYB, red, yellow, and blue. And then here's their relationship on the CMY model. So your red is here, your blue is here, and your yellow is here. Why are they set up in a what's called a trichromatic relationship? There have been many models over the years. Some are made of 5 colors, some have been made of 7 colors. But the ones that seem to survive are the ones that are made of 3 primary colors. And we're going to stick to that model. So when we work with RGB, it's a trichromatic color system. When we work with CMY, it's a trichromatic color system. And we work with RGB, it's a trichromatic color system. So that's it on the color models. The next one we'll talk about will be the actual color wheel.